Hello, you're welcome to our math classroom. Don't forget to subscribe and click on the bell to receive notifications on any new video we upload. Like, share, and comment as well. So we are looking at Laplace transform today. The transformation is very important to the engineers in solving differential equations. And if you are looking at waves as well, then it's very important. So it's important because then you are talking about time. So with time of rates, flow, waves and all that, then the Laplace transform is a necessary tool to solve those kind of functions. So we are looking at a transformation of a function. So we are looking at a function where we are transforming a function of f of t to a function of what? S. Okay. So, and the Laplace of a function f of t is defined by the improper integral e s t, the function f of t dt. This is the definition for a function, an improper. So this is an improper integral that we are looking at. So let's look at some properties. If I have let's say I have f of t, I have f of t to be equal to what? K. Means that I'm looking at the Laplace transform of what? K. Okay, so that is what I'm looking at, which is K. If K is a constant, then I'm looking at a transform where I have K L of what? 1. Okay, so you can always bring your constant words out. So with something like this, let's take an example of a common function. Let's say f of t is equal to 1. So I'll come back to K again. It means that I'm looking at the Laplace transform of 1, which is going to be the integral e of st. The function is what? 1 dt. This is what I have. If you remember, for improper integral, this could be written as the limit as a approaches towards infinity. I have the integral 0 to a e exponent minus what? S what? dt. Okay, so if you solve for this, what are you getting? I have e exponent minus st over minus what? S, from 0 towards infinity. This is what I have. Now let's use the limits. If I take the limits, as a approaches infinity of the function e exponent minus st over minus s, I have 0 to a. Then what am I getting? I'm getting the limit as a approaches infinity, e minus xa over minus x exponent e exponent 0 over what? Minus what? S. Okay, so you realize that if I take the limits of this as it approaches infinity, then it is going to go to 0. And we know that any number raised to the power 0 is what? 1. And this is negative, so it will cancel out to be what? Positive. So you realize that I have 1 over what? S. So it's saying that the Laplace transform of 1 is equal to what? 1 over what? S. So with the Laplace transform of k, the Laplace transform of k, which is a constant, then it's going to be what? K over what? S. K over what? S. Let's take another example. Let's say this is example what? 2, where I have f of t to be equal to what? E raised the power a t. So let's look at the Laplace transform of e exponent t a t to be equal to the improper integral 0 to infinity. What do I have? I have e minus st dot e a t d what? dt. This is what I have. So you remember our indices, because the bases are the same, and it's good that you can find the sum. So I have 0 to infinity e exponents a minus what? S t d what? dt. Now let's find the integral of the exponential. If you take the, so what do? We find the derivative of the function and the exponent, then we divide by the whole exponential function. So what are we getting? We are getting e a minus what? S t all over what? A minus what? X, from what? 0 to what? Infinity. That is what we have. So we have 0 to infinity. Now let's look at the function. Let's say we have the exponential part, that is a minus s. If a minus s is greater than 0, if this whole thing is greater than 0, you realize that the result of this will be infinite. So you're going to have a bigger value. So it's just an infinite value you are going to get. You can't tell. So then it's going to be, it's going to not defined. Then if I have, let's say a minus s less than 0, this is the same as having what? It's just as writing a to be less than what? S. If a is less than what? S, then it means that this is going to be what? Negative. We are going to have a negative value here, a negative value here. And if you have an exponential of a negative value, you realize that it is converging towards 0. It is converging towards 0. So then you realize that this approaches towards towards 0. That is what you have there. So then with this I can actually solve. So from here we realize that it's going to give us what? 1 over a minus s. So since this will go to 0, I have 0 minus the 0 part. We know that any number raised to the power 0 is what? 1. So what do I have? I have what? Minus what? 1 here. I hope we are getting that. Okay. So from here, what do I have? So I have minus 1 over a minus what? S, which is equal to 1 over x minus what? A. So this for s greater than what? 0. So this is going to be for s greater than what? A. S should be greater than a. Okay, because I said a is less than what? S. Okay, let's take another example. If I have a third example, let's say my f of t is equal to cos at, where my a is a constant. So I'm looking for the Laplace transform of cos at. Okay, so let's write it. The improper integral 0 to infinity e exponent minus xt cos at dt. Okay, so with this Laplace transform, you will need your integration so much, so I urge you all to do a revision on your integration if you are still not getting what the concepts. Okay, so you realize that you have what, two functions here. You have an exponential function and a trig function. So if you have a product of two functions like this, the product of two functions, and we can use integration by parts. Integration by parts. So if you do that, if you use your integration by parts, which I'm not going to do here because we've already done that, then we are going to get e exponent minus s of t over s squared plus a squared into brackets a sine at minus s cos at from 0 towards infinity. 0 to infinity. Okay, so do the, if you take the same thing like our previous example where we have the exponential part with the infinity, if our a is, so we have the exponential part here. So if our x is what, negative, if s here, if our s here, let's say this s is greater than 0, then we are going to have a positive value here, so it's going to work out. But if we have our s here to be less than this s, if it is less than 0, which is a negative number, then it's going to make this word positive, making it what, undefined. Okay, so if you solve, we are going to arrive at e exponent s, the minus infinity part, so everything is going to go to 0. Then we are going to have this part, so that part, the infinity part, will go away, then we'll be left with this part, because 0 is going to go away and the sign of 0 is going to go to 0, then cos of 0 is going to go to what, 1. So we are going to have the other parts, so all this part is going to go to 0. So I'm going to have this part e 0 s 2 plus a exponential 2 into brackets a sine 0 minus s cos 0. Okay, so this is what I'm going to have. This we already know, any number raised the power 0 is going to give us 1. So we already have what, 1 there, 1 here. So with this one, let's not, this will also go towards 0, because, and this will also go towards 1. So you realize that I'm going to have minus 1 over s squared plus what, a squared minus what, s, and it's going to give us, our final answer is going to be what, s over s squared plus a squared, on the condition that our x is greater than what? 0. The condition that our x is greater than what? 0. So you actually can't do this if your integration is weak. So I urge you all to do a revision on your integration. Thank you. So our next lecture, don't forget to subscribe. May that